right, so this is the last section in the systems one. And so we're going to talk about linear inequalities. And these are like a linear equation, but you're going to shade. You have more than one answer. Okay, so a solution is all of the ordered pairs. Okay, so if you look at the first one, they're asking you to take 2 and put it in for x, so 2 times 2, minus 3 and put 5 in for y, and they want to know if this is part of the solution. So this is 4, and this is 15, and so is a negative 11 less than 15? The answer is yes. Okay, and I'm not going to do all of these. Let's just go ahead and do the third one. So again, you have an x and you have a y, so you're going to do 2 times 3 minus 3 times a negative 4, and you want to know, is that less than 15? So this is 6, and this is a plus 12. So you end up with 18 is less than 15, so the answer is no. So some points work and some points don't, okay? You're going to put the inequality in slope-intercept form, which means, remember we've been doing this for a couple of days, that means you're going to, I'm going to put this underneath here, you're going to solve for y, okay? Then you're going to use a solid line if it has an equal to sign underneath it, and you're going to use a dotted line if it doesn't, okay? And I'm gonna, you're gonna shade above if it's greater than or equal to, and you're gonna shade below if it's less than or equal to. But I kind of hate this one because this stuff has to be after you solve. Okay, so you can't tell, if I look at this first example, you can't tell from the way that it's written. Okay, you have to do it from where you solve. So if I were to solve this one, I would minus 2x and minus 2x, and I get a negative 3y is less than 15 minus 2x. Now I'm going to divide everything by a negative 3, which actually flips my sign. Okay, we've been graphing, so you go through at a negative 5, and you're going to count up 2 over 3. Okay, it does not have an equal to sign on it, so I'm going to make a dotted line. And then you're looking at it, it's greater than, so you're going to shade above the line. Okay, all right, so let's take a look at some of these. We're not going to do all of them. We've been graphing lines, so let's take a look at example 1. It's solved, so I'm going to go down 1, 2, 3, 4, 5. And then I'm counting up 1 over 3, up 1 over 3. I could also go down 1, back 3, down 1, back 3. It doesn't matter. This does not have an equal to sign, so I've got to make a dotted line. It is solved for y, and it's greater than, so I can use this. I'm going to shade above because it's greater than. So you can use your notes to help you. Okay, let's take a look at number 3 because that's different. It's not solved for y. So I'm going to minus 5x and minus 5x. And I get a negative 2y is greater than 12 minus 5x. Then I divide everything by a negative 2, but when you divide, don't start doing this again, you have to flip the sign. So this becomes a negative 6 plus 5 halves x. So you go through 1, 2, 3, 4, 5, 6, and then you're counting up 1, 2, 3, 4, 5 over 2, 1, 2, 3, 4, 5 over 2. I can keep going, but it is a dotted line. And if I look, this sign right here is less than, and if I go back to my notes, a less than sign, you shade below. So I'm going to shade below the line. Okay? All right, so let's take a look at number 5. On number 5, I have to solve for y, so I'm going to minus x. I get a negative y is greater than or equal to 8 minus x. You can't have a negative y, So I'm going to divide by a -1, and y is less than or equal to, because you divided by a -8 plus x. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, and I'm counting up 1 over 1, 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 and I'm making a solid line because it has an equal to sign. And if I use my cheat sheet, this is less than, which is less than, so I'm going to shade below the line.